All right, quick story here. We've been studying a triangle for the last 2 units now, unit 4 and this one. I don't know if you guys realize, but to form a triangle, you just cannot have any 3 sides that you want. Like if I have 3, 20, and 15, that won't form a triangle if I have side lengths 3, 15, and 20. It has to fit a special pattern, which you guys are going to find out today. I just want to introduce this by saying to form a triangle, you cannot have any 3 sides that you want. Okay, and it's got to follow a special formula or a pattern, which you guys are going to find out now. So we got a little group activity going on here, right? We got a little group activity to figure out, well, how can you determine what the side lengths could be to form a triangle? You'll see right away on this first activity, each member of the group should take turns picking straws. That's not how I roll in here. All right, straws, come on, we deserve a little bit better than that. I should be giving you a lot better than that. So instead of straws here, we got some good old licorice here that we're going to use. All right, straws are that's not going to do. So here's the deal. First part of this activity in your group, I'm going to make sure everyone's got rulers here in a second. You guys are going to take a piece of the Twizzler and cut up a 2, 3, 4, 5, and 6-inch piece for me. Okay, so you should have 5 pieces on your desk in your group right now after we're done. A 2 through 6-inch pieces. And that's all I want you to do. Okay, that is all I want you to do first. Please make sure they're pretty accurate too, or this activity doesn't go so well. We're not even there yet, Via. Relax. Okay? Just cut the darn things up. You guys got one. You guys need one. You guys have one. Got one. Join a group, Aiden Cripe. Join a group. You guys, so we're all set. Okay. Now. Thank you. Okay, these bad boys say they are 16 inches long, so each group should be fine with 2 of them. I'll give you 3 just in case you mess up or you get a little, get the munchies, you know what I'm saying? So cut your pieces up first for me. Let's roll. Cut your pieces up first. Cut them up for me. Make sure you know which piece is how long. 2. Let's start cutting them up. Crazy. Oh, yeah. Yeah. Start cutting them up. Yeah.
See the bowl? That's someone else. Grab.
You play with your calculator as
Oh.
Two through 6-inch pieces, so you should have 5 pieces in your group at the end. Not individually, for your whole group, 5 pieces. 2 through. So the next part, your group's going to pick 3 lengths. Record those 3 lengths in your chart. And then you're going to see if you can form a triangle with those 3 pieces of licorice. Now, what qualifies as a triangle? All 3 vertices must be touching. This right here would be a no. If it goes past and forms an exterior angle, that's also a no. All right? What I'd like you to do in your group right now is find 3 yeses that do form a triangle and 2 nos that do not form a triangle. If there's controversy, call me over. I'll settle the debate. Okay? Find 3 yeses and 2 nos for me. Find 3 yeses and 2 nos. So pick 3, write down their measurements, see if you can form a triangle. 3 yeses and 2 nos. Call me over if you're want to ask if this should be a triangle.
We got 2, 3, 5. Oh wait, it'll just be
Don't try to stretch your licorice.
We got a 5 on bottom. We got a
3 yeses, 2 nos.
We got a.
Okay, so we don't. Is this yeah, the same. So
All right, let me go around to the groups here. This first group here, give me 3 values that got you a yes triangle.
3, 4, 5.
Yep, 3, 4, 5 should have been a yes triangle, everybody. 3, 4, 5. Second group over there, give me another set that give me a yes. You guys right there. Jackson, Lisa, Molly. Which one? 4, 5, 6. Yep. That's also a yes. And Josh, via your group back there, another one more yes. 2, 3, 4. That's a good one. All right, so those formed a triangle. What about the nose now? Fellas here, will you give me a no one?
2, 3, 5.
Yep, that should have been a no. That did not form a triangle. And how about one more no over there, that group of 4? One more no? 2, 3, 6 did not either. Yep. I'll even add in a third one here. No, I won't. Will I? 2, 3, 6, 2, 3, 5. 2, 4, 6. Well, it would also be another no. 2, 4, 6. Yep. All right. What I want you to do right now, about a minute, take a look at the sets that got a yes and the sets that got a no. What can you come up with? How am I going to know, looking at 3 sides of a triangle, if it's going to form a triangle or not? All right, so discuss it within your group right now before we come up with an official theorem. Look at all the no's and look at all the yeses. How can I tell if it's going to form a triangle or not? All right, let's get back. In your own words, before we put an official title to it. In your own words, how can I look at 3 sides of a triangle and figure out? Remember this one I showed you at the beginning of the class? I said, no, that's not going to form a triangle. Do we know why now? Anybody got a little, Romeo, what do you got in your own words?
Because since you have one side and there has to be like another that's meeting, if they're less than, if they equal the same as the one side.
What do you mean they equal? Like if I subtract, divide?
In addition.
Okay, adding 2 sides up has to be what?
Has to be greater than the length of one side.
The other side, right? Yeah, there you go. Okay, so let's officially put this into our triangle inequality theorem, which says the following. In a triangle, ready? Sum of 2 sides. What do I mean by sum? Sum? Adding, yes. Sum of 2 sides must be greater than the third. Notice I didn't say greater than or equal to. Greater than the third. So I take any two sides, I have to add them up, it has to be greater than the third, and that has, hey, listen, that's got to work for any two sides I pick. It's just not, oh, these two sides work, so that's okay. It's got to be any two sides, every two sides I pick. Add them up, it's got to be greater than the third side, you got a triangle. If it's not, no triangle can be formed. All right, so let's go around here. This isn't multiple choice, by the way, number one. Number one's not multiple choice. I want to go through parts A, B, C, D, and E and see if it actually would form a triangle. If it doesn't, be prepared to back yourself up and tell me why. So if I have a triangle that's got side lengths, 1, 2, 3, is that going to form a triangle? Why not? Why not? Wait. 3 plus 2, that's bigger than the third side 1. What's the problem, though? 1 plus 2, not bigger than 3. Okay, it's got to be greater than. So does everyone see? Even if you find one outcast, it's not a triangle. 2, 4, 5 look good or no? 2, 4, 5. Add up any two sides. Will it always be bigger than the third? Darn right it will. 5, 5, 6. Yeah. Bonus. What type of triangle is it? Yeah, there you go, studs. Isosceles. 8, 13, 21. No? What's the problem?
If you have 13, you have 21.
Yes, 8 and 13 is not bigger than the third side. It's equal to the third side. That's a no spot. And how about 10, 20, and 25? Yep, that'll form a triangle. All right, so that's one part of today is, can it form a triangle? Second part, if I give you two possible sides, what are possible lengths of the third side? So first question here, I got a triangle. It's got lengths of 4 and 7 inch. Okay, let me get on the pen, huh? 4 and 7 inches. What are possible lengths of the third side? And then I'll tell you how I want to write it, okay? Because I just don't want a list of numbers. I want something a little bit cleaner. But for now, give me possible third. Any side? 100 work? 100? Absolutely not. It's got to follow my rule. I can only have certain side lengths here. You can't just throw on anything you want. Molly, one side length. 10. Would 10 work? 10 work? You take a look. Add up any two sides. Will it always be greater than the third? 4 plus 7, 11, greater than 10. 4 plus 10, 14, greater than 7. Yeah, 10 works. There's more, though. I want to try to get all of them out of you right now. Zach, 4. Does 4 work? 4 and 4 give me 8. That's bigger than 7. 7 and 4 give me 11. That's big. Okay, 4 is good. There's more, though. I want all of them out. 5. Oh, here we go. Now the ball starts rolling now. 6. Yep. 7, 8, 9. Can I go 11? 11? Why not 11? 4 plus 7 would equal it. Can I go 3?
Yes.
I can?
Oh, wait.
Why not? Because 3 plus 4 is going to equal 7, not be greater than it. All right, so here's my possibilities. But I don't want to list the numbers. Let's clean this up. You may or may not remember this last year in algebra, but you did something called compound inequalities, where it was 2 inequalities at the same time, something like this, like your values between 3 and 6. That's how I want you to write this. Your side is x, and what does x have to be in between? Because this is, this is great, but I need a little bit cleaner. So my side length, x, could be in between what two numbers here? Okay, hold, everyone, don't write anything down, because we might take a while to get to this final answer. So I put 4 and 10 there, right? 4 and 10. But, hold on, still don't write anything down. Doesn't it include 4? 4 could be a side, we said, right? But my inequality says 4 is not included. Remember the symbol, greater than or equal to. Still don't write anything down. You might think this, right? You're like, what's the issue? I got 4, I got 10, everything in between. What's your problem? Ready? Would this side length work? 3.9? What's 3.9 plus 4? 7.9? Is that bigger than the third side? So would 3.9 work? But it isn't in my inequality. No, but it should be, because 3.9 works. So how about 3.1? Would 3.1 be okay for a side length? It's not in your inequality. Would 3 work? We already said no, right, for 3? Okay, you want to readjust my inequality? What should I put on the ends now? What do you think? What should I put on the ends now? Molly? 3 and? You sure you want to make it or equal to 10? Because here's why. Ready? Here's my same argument going the other way, Molly. 10.1. 10.1's okay. 10.9's okay. Just 11's not okay. So I should go from 3 to 11 with no or equal to. There you go. 3 to 11 with no or equal to. Because I got to make sure I represent those decimals. Now that took us a while. And I am not expecting you to write out all the possibilities and try to figure this out. So is there a way I could get to these n values a little bit quicker? Let's take a peek. Everyone, at the very beginning of the problem, your original 2 sides were 4 and 7, weren't they? 4 and 7. And what were the ends of my inequalities? 3 and 11. Any way I could use my sides I give you to get to the ends of the inequalities pretty darn quickly now? What's up, Scott?
You can add the 4 and 7 to get the 11, and then you can subtract the 4 and 7.
You can add and subtract your sides to get to those values, correct? That's the shortcut, all right, to what we just did. So 9 and 17 now. Problem number 3, 9 and 17. I don't want you to list them out anymore. All right? My side could be in between. Go ahead, subtract them. 8. Between 8 and? Yeah. Understand why I don't want you to list them? That would be a while, listing out all those values. So my side could be anywhere between 8 and 26. And what about number 4 if I had sides 11 and 20? The third side could be between 9 and 31. Could be between 9 and 31. All right, so there's the shortcut without having to list all of them out. 2 things. You're going to start your homework right now and possibly finish it because you still have 17 minutes. Second thing, you got to either eat the licorice or you throw them away. Don't leave them on the desk or on the floor, please. Throw them away or eat them. I don't care. Go to town. Let's get your homework done.
I'm feeling